Good evening, Honorable DG Nice, Professor Mohammad sir, Honorable DDSP Professor Ambusagar sir, respected Mr. Jitendra Rautre sir from ReNew, respected faculty members and my dear friends, I sincerely thank you all for joining this energizing lecture series and announce that this session is started. I request Professor Mohammad Rihan, Professor Ambusagar, and Mr. Jitendra Rautre to come to the dais. And I'm now handing over the mic to project scientist of our ReNew COE, Monica Mishra, to take the event forward.
Sir, please be seated, sir. PPT, यहाँ भी copy करना है, वहाँ भी copy करना है. Sir, please hand over to her. Good evening, everyone. Myself, Monica Mishra, Project Scientist and Coordinator of ReNew Center of Excellence, would like to extend a warm welcome to our esteemed guest, Dr. Mohammad Rihan, Director General of National Institute of Solar Energy. It's my extreme pleasure to welcome Professor Ambud Sagar, Deputy Director of Strategy and Planning, IIT. We are fortunate to have you both join us today, sir. As a small token of appreciation, I would like to request Professor Ambud Sagar to present a bouquet to Director General of NICE, Professor Rihan. It's a symbol of our gratitude for your valuable contributions in energy sector, sir. Requesting Mr. Jitendra Rautre, sir, Head CSR, ReNew, to present a bouquet to Professor Ambud Sagar. I would like to invite Professor Sumit Chattopadhyay, co-coordinator of ReNew Center of Excellence, to present a bouquet to Mr. Jitendra Rautre. Requesting Ms. Neeti to present a bouquet to Professor Sumit Chattopadhyay. So everyone, let's give a warm round of applause for DDSP sir as he takes the stage. Sir, may I have the pleasure of inviting you to share the welcome address with all of us? Please, sir.
Good evening, everyone. It's a real pleasure for me, actually, to be here and to welcome Dr. Rihan for this lecture. Actually, there are many reasons why this is a very timely lecture. First of all, it's part of our energizing lecture series from the ReNew Center of Excellence, which is a partnership between IIT Delhi and ReNew, which is kind of the right model in today's world for academia and industry to be working together on the big questions of the day. And I think there is no probably, in terms of big issues of the day, there probably is solar energy is up there. As you all know, we're undergoing, actually globally, a major energy transition. And in the last few years, investments in renewables have far outstripped investments in fossil energy. In fact, last year, if I remember correctly, the investments in renewables globally were about $1.8 trillion, and fossil was about $1 to $1.1 trillion. And of that $1.8 trillion of global investment, the dominant investment was really in solar photovoltaics, because that is seen as really the center pin or the center piece of the energy transition. It is completely driving a move towards away from carbon and helping in the climate mitigation. And in a sense, the story has only started. And so the title of today's talk, Capacity Building in the Solar Sector, becomes particularly relevant because one, implementation, actually both the production and implementation of solar photovoltaics very much require different kinds of capacity. And as I said, given the fact we're very early in the energy transition, we still have a long way to go. And therefore, solar is going to continue to be playing a major part in the years to come. Capacity is going to be more and more needed. So it is both different kinds of capacity and much greater amounts of capacity that's going to be needed in the solar sector. And therefore, for the kind of students sitting in the room here, for you guys, it's actually an amazing professional opportunity to be able to be part of this story and to actually be the capacity building we are going to talk about. You guys are real life examples of the capacity, of the kinds of capacity that needs to be built in order to propel this solar sector forward, and also to keep the energy transition, the momentum in the energy transition going. So I think it's going to be, I'm sure, a very, very interesting lecture. Unfortunately, I won't be able to stay because of other obligations, but I'm sure you guys are in for a treat to get a sense of what is the kind of capacity needed in the solar sector, and therefore what does it mean for your professional lives, and how you will be able to take advantage of this kind of emerging opportunity in the solar photovoltaic space. So again, thank you very much, Dr. Rihan, for being here and finding a time to meet with our students. Today, because of the exams, I think the audience is a bit sparse, but if you're indeed going to be doing some kind of agreement between IIT Delhi and NICE, then we will have other opportunities to get you back on campus and engage again with our students. So, so thank you again for being here. And welcome to all of you, and to a very exciting talk that's going to come.
Thank you so much, sir, for sharing your invaluable insights with us. Now, I would like to request Mr. Jitendra Rautre, Head Corporate Social Responsibility from ReNew, for presenting an overview of ReNew Center of Excellence. The dice is over to you, sir.
Good evening. It is my pleasure to welcome all of you to ReNew Center of Excellence lecture series. Let me also extend my warm welcome to Professor Rihan and also Professor Ambus Sagar and Professor Sumit Chattopadhyay for their time and effort. Let me tell you, this ReNew Center of Excellence, it is the vision of our chairman, Suman Sinha, who vision helps create this center of excellence, and also the support from the our center coordinator, Professor Nilanjan Sen Rai, Professor Sumit Chattopadhyay, and other professors who have been working hard to make this center to the greater level. Finally, the hard work of all the students, those who are associated with the center, and they are doing a lot of work, not only related to research, but also other activities as well. It is indeed a pleasure to represent ReNew Center of Excellence, which was initiated in the year 2016 under the Industry Academia partnership when Mr. Pranab Mukherjee was the president. He called some of the industries. ReNew was one of them, in a way to come up and give this idea to establish a center of excellence at the premier institute like IIT Delhi. Since then, we have been working hard, and with the support from all the professors and students, we are undertaking a lot of research projects around renewable energy, and also we are doing a lot of activities which is beyond research. For example, Thought Leadership Series, this is one of the activity under Center of Excellence. We also conduct every year, 3 or 4 lecture series we conduct. In addition to that, we also support startups, student startups. We also provide fellowship programs. We also, in a way, collaborate with like-minded institutions. Like recently, we are going to renew our partnership with Columbia University, which will be like tripartite agreement between IIT Delhi, ReNew, and Columbia University to explore research areas under renewable energy. Without much ado, I will not be taking much time. So this is indeed a great pleasure to be a part of this forum, and also it is my privilege to welcome Professor Rihan to address the students and to give his views about capacity building in solar energy sector. Thank you so much.
Thank you so much, sir, for your words of wisdom. So now, everyone, we have had a wonderful evening so far, filled with lot of excitement and meaningful exchanges. But as they say, the night is still young and we have more treasures to unveil. One of the most awaited moments of this evening has now arrived, a moment that promises us to deliver insights and inspiration to engage all of us in a thought-provoking session. It gives me immense pleasure to invite our distinguished guest of the evening, Professor Mohammad Rihan, Director General of National Institute of Solar Energy. Professor Mohammad Rihan is serving as Director General of National Institute of Solar Energy, Gurugram. In this position, he is leading the research and development and capacity building initiatives in the area of solar energy in line with the national requirements. He is serving as Chairperson of Sectional Committee on Solar PV of Bureau of Indian Standards and Chairperson of Technology Advisory Group Solar Energy ARCI. Before joining as DG NICE on deputation, Dr. Mohammad Rihan worked as a professor of electrical engineering at AMU for about 22 years with significant contributions in the areas of smart grid and solar energy. He has led the integration of 6.5 megawatt power solar PV plants in the campus distribution grid, one of the largest such installation in any academic institution in the country. Two of the PhD works under his guidance have been awarded the Prime Minister Research Fellowship. Dr. Rihan has authored a textbook on green energy and sustainable development to be published by Cambridge University Press, UK. He has also completed sponsored research projects of UPCST, MNRE, and UGC. He has provided technical consultancy to various projects of Smart City, Agra, Aligarh, and Bareilly, and to the UP Power Transmission Corporation Limited, and has delivered keynote and invited talks on climate change, solar energy, and smart grid at numerous organizations, industry, and institutes. He is a recipient of gold medal for securing first position in BTech Electrical Engineering. He is elected fellow of IET UK, IE India, and IETE, and senior member of IEEE. At present, he is chair-elect of IEEE UP section and elected vice chair of Executive Committee of Delhi Local Network of IET UK. Thank you so much, sir, for accepting our invitation. So everyone, without further ado, let's welcome DG NICE Professor Mohammad Rihan on stage. Sir, please grace us with your insightful knowledge and enlighten us with your wisdom. The stage is all yours, sir.
So which one? IITD, 7th May. This one. Thank you. This point.
Dr. Sumit, Jitendra ji, my friend, Dr. Nabi Hassan, librarian, all the faculty members, all the students, a very good evening to all of you. Not sure how good it is a time for you all to listen to me, but let me try to make sense of what I am going to talk here. See, I was telling this to Jitendra ji that I feel I have gained experience, I have seen this sector from 3 different angles. I am a professor of electrical engineering, and so having worked for more than 20 years in that capacity, I have some idea of the academic side of the issues. Then during my tenure at Aligarh, we did some major projects which were actually industrial projects. So that gave me a good idea of the field experience of that. Now I am serving for more than 1 year as DG of National Institute of Solar Energy. So that has given me some perspective, some idea of the policy side of it, the policies, the schemes, the national scenario and all. So what I have, I thought, what should I talk here? So I thought that let me try to convey the essence of what we have gained through these 3 different angles from which I have seen it. So it is not going to be a routine talk of an academic, which is more towards research or something like that. The idea here is I want to convey 2-3 important points which I try to convey from my own experience too. Whenever I get to meet the people from academia or the students, and fortunately I have some representation of industry also. And you will realize from my presentation that why I have deliberately agreed or why I have come for this talk is I really like this idea of joining ReNew with IIT Delhi, because this is the way forward, this is the requirement. So let me the DD strategies and planning. He mentioned about how solar energy is growing, how it is being adopted. So I'll start with some background and then I'll come to some of the issues and all. Can I know how many of you are from electrical engineering background? Can you please raise your hands? So that means I have a good combination of people from different branches, different fields. I am from electrical engineering, but whatever I am saying on this slide is not because of my special love for electrical engineering, because I am from electrical engineering. I just want you to realize that the time we wake up in the morning until the time we go to sleep, what is the role of electricity in our life now? You will realize that almost every action, whether in our personal life, whether in our official life, whether in our studies, is somehow or other connected with electricity. We usually say that this is an era of digital. This is a digital society. This is true. We call it a digital society, but often we ignore the fact that electricity is what makes this digital society work. And if you want to realize the criticality of anything, just imagine the absence of that for some time. So that is why if you read the last line, electricity is like air for us now, because we feel only the absence of it. Till the time it is available, it is running the world for us. We are not exactly appreciating it in that way. But when it is not available, we realize what is the importance of that. And if you go back, how it started, it was invented just for the basic reason that once the sun sets, let me have something to get some light. That was the basic idea. But how it has expanded and it has covered everything. Somebody has written that the world is a prisoner of the wires of electricity. And I hope some of you have been following the news of recent events in some European countries, how the breakdown in electricity led to the crisis. And I hope some of you were old enough, because I have mostly the students. In 2013, we had the last major, 2011 probably, we had the last major blackouts in the country for 2 days, how everything was at a standstill sort of thing. So this is the importance of electricity now for everybody. And this is the system which makes it work. And the National Academy of Sciences, USA, declared the electric power grid as the number one, the best invention of 20th century, beneficial for humanity. Why? Because you see, there are thousands of generating stations, lakhs of kilometers of transmission line, thousands of substations, but everything working as a single machine, virtually a single machine. Those from electrical engineering, they know when I am saying single machine, what does it mean? So basically, this is what is making our world work for us. This is the engineering marvel. Now, I have talked about the criticality, importance of electricity. I am slightly digressing, and I am going to something which all of you are following, and which we are calling as an existential crisis now. What is that crisis? That crisis is the level of carbon dioxide emissions is the highest in the history of the planet. I am citing just few numbers. Before industrialization, the CO2 concentration in the atmosphere was around 280 ppm, and at present it is 423 ppm. This rise has led to an increase in the average temperature of Earth's surface by almost 1.2 degrees. Now you will say that 1.2 is not a major number, because we see temperature variation 3-4 degree, 5 degrees daily. But this is average temperature of Earth's surface. And some studies have shown that the excess amount of heat which is available in the atmosphere because of this increase in CO2 is equal to if you release almost 1 million of nuclear bombs of Hiroshima bombing size. That much extra heat is available there in the environment. This is what we are calling as global warming, and some people have started calling it global boiling. And it has come beyond any discussion now, because the events are everywhere to see. I am citing just 2 recent examples. Gorakhpur is a district in eastern UP. So the doctors were surprised to see patients coming with a skin disease which is seen in deserts only. Then it was seen what is the pattern of temperature and all. So in that region, in 2024, there were 39 days when the temperature crossed 40 degrees centigrade. And in the same region in 2021, there were only 6 such days. Second thing, which I am sure you must have observed, 26 January this year, the temperature in Delhi was almost 24 degrees, which is absolutely abnormal, because we all are used to seeing 26 January as a chilly mornings and all. So these are the signs and indications available everywhere. This I am sharing especially because it is our national concern. The Intergovernmental Panel on Climate Change has identified these are the threats for India also. Because why? Because we are a large geographically diverse country. We have all regions which are prone to adverse impact of global warming. Now, I wanted to make this connection actually. I started with electricity, I talked about global warming, and now I am making the connection that there is a direct connect between global warming and electricity. generation, and why we are generating, because you want to consume electricity, so consumption is directly connected to CO2 emissions. So when I generate electricity by burning coal, which has been the most commonly used method, it leads to almost 850 gram of, on an average, CO2 emissions. On the generation side, if I take into account the distribution losses, transmission losses, it is 1:1, 1 unit, 1 kg of CO2 emissions. Now, whether we like it or not, if a country is growing, if it wants to be developed country, it needs electricity. So what is our requirement? What is our scenario? You see how we are growing. Our grid, which has almost 470 around gigawatt of installed capacity now. In 10 years, we have added capacity which is more than countries like France. With this much we have added. And where we are headed to, our requirement will surpass Europe and USA in the coming decades. And our system will expand to almost 8 times in the next 25 years or so. So I want you to connect these 3 parts now. This is my requirement. If I continue meeting it by the same conventional method, then this challenge is there, and this is leading to these problems. And I cannot ignore, I cannot simply say that switch off everything and do not use electricity. That is not possible. So under this scenario, this is the international development. I am sure you all are aware of 17 Sustainable Development Goals. This is a concern for every country. And the importance of energy, clean energy, can be understood from the fact that one of the SDGs is devoted to clean energy only. These are the targets under goals of under 7, SDG 7. So this is the background in which we want to make our grid, our system greener. We want to decarbonize the electricity generation, transmission, distribution, consumption. So I define this is a 3-pronged strategy. This is reverse actually, this should be the first one. First one should be this one: promoting energy conservation, increasing energy efficiency, shifting to green energy, and sector shifting, like we are shifting transport from fossil fuel based sources to electric vehicles. So this is what, and this is something which is every country is doing. This is not that only we are concerned with this. Every country is, because as I have mentioned, you cannot live without electricity, and you cannot live with electricity which is generated with associated CO2 emissions. So that is the challenge. So under this scenario, we have had different terminologies, but we have been consistent on this, that we want to have a green and renewable energy system for our country. So initially this target was 20 gigawatt of non-fossil fuel based energy sources by 2022. Then it was revised to 175 gigawatt. And then it was said that by 2030 we will have 450 gigawatt of non-fossil fuels, which is further increased and revised to 500 gigawatt of non-fossil fuel based sources by 2030, which includes 292 gigawatt of solar energy. I am sure you know gigawatt, megawatt and kilowatt relationships. So if I tell you the journey of solar in India only, in 2011 we had only 10 megawatt of solar energy installations in the whole country. 2014 or 15, it was around 2.6 gigawatt or 2.7 gigawatts. and at present it is 107 gigawatt, more than 107 gigawatts. See, almost 105 gigawatt of solar energy has been added since 2015. And in next 5 years, what we want this 107 is converted into 292. Nowhere in the world any electricity system has seen such a huge transition from one form of energy source to another form of energy source. And I want to highlight here this I have deliberately mentioned renewable / green. See, all of us, when we study, I have studied in engineering, I'm not sure of how you are studying right now, but for us, the main concept was renewable energy. And how it started in 80s, we had some oil crisis in the world. And then people were concerned that coal is something which is limited. If we keep on using it, it will be exhausted. So let us support it with some renewable energy sources. So that is why you will see around 2010, up to around 2010, the focus was on the renewable property of solar energy, wind energy, or biomass, or some other sources. But now we are not talking of saving coal or supporting coal. Now the talk is replacing coal. And the focus is not being renewable, the focus is on being green energy source. Renewable as well as green. And for this discussion, when I am saying green, it means when you generate electricity by using this source, it does not contribute substantially to CO2 emissions. So, I have mentioned this ReCE already. Since 2017 in our country, the new addition of non-fossil has always been greater than the fossil sources. I have already mentioned the share of solar energy in installed capacity. If I talk in terms of energy mix, that is at any point of time, how much share in the actual generation, it has already crossed 10%, and by all accounts, it will reach around 23% by 2030. And this is what I was talking about. Somebody has said that Stone Age did not come to an end because stones were exhausted. The same we are expecting for coal in terms of electricity generation. So we are not bothered whether it will be exhausted or not. We want that we should not use it for electricity generation. Okay, so this I have given you an idea. I want you to, from the numbers, I want you to appreciate the scale of transition. So you have come from 2.5 gigawatt to 107 gigawatt, and you are going from this 107 to 292 by 2030. If I give you slightly further numbers, almost 1500 gigawatt by 2047 and almost 5000 gigawatt by 2060 or 65. So this is how the whole system is getting solarized. So this is one thing which I wanted to highlight. Second thing is there are many new development also in this area. So which I show you here. For example, there is a challenge of how do I install solar systems when there is no rooftop or ground space available? For example, the high-rise buildings. So this is an area of which we call as building integrated PV. This is gaining attention. Some of the countries have already developed these products. These are actual pictures. And we want our country also to start and develop competencies in this area. This is second new emerging technology where you install the solar panels on a water body, floating solar power plant. This is an actual plant installed in near Indore, MP in Omkareshwar. It is a 280 megawatt floating solar plant, and this is the largest floating solar in India right now. And it is being expanded also. So this is another something which is gaining attention and importance. Then there is a talk of how we can combine agriculture with solar energy. How we can combine agriculture with solar energy. So can I increase the height of solar panels and have agriculture under those panels like that, or in between the panels? So this is agri PV, agri photovoltaics. These are many examples of this from India as well as from other countries. This is another area which is gaining lots of attention. And then this is a recent development under exploration. So I hope you have heard that recently new type of panels have come up. These are called bifacial panels. They generate electricity from both the sides. So can I install these panels along the highways or in the middle intersection of highway and generate electricity using that? So these are some of the recent developments. Apart from this, another area is how to increase the efficiency of cell as well as the module. This is a very actively pursued area for, I would say, decades now, and it will remain an actively pursued area for decades to come also, because you want to, and you know, we have come from in 1.5 decade from around 15-16% efficiency panels to 24 and beyond 24% efficient panels. But this is something which is going on. So these are some of the areas which are getting so much attention. So this I have tried to give you a picture of what is happening and why it is happening. One more in terms of national development. 4 or 5 years back, we were completely dependent on imports for modules, panels. Solar panels are actually modules, and cells. So now this manufacturing has also come up in a big way. And already in India, 90 gigawatt, around 90 gigawatt manufacturing capacity of modules is in place. Around 10 gigawatt of manufacturing capacity in cells is in place. And it is expanding day by day. So now, since this all is happening, when you have such a large scale change going on, you need people to work in that area. So the solar sector needs people who can cater to different subsectors of this area. That is why it is believed to be one of the most important employment source also for the country. There are estimates which say that almost 19 lakh jobs in solar sector only will be there by 2030, and 6 lakh jobs in green hydrogen. So you need people at different levels. You need the basics, entry level, technicians, installers, operation and maintenance people. Then you need middle level people, engineers, project managers, supervisors. Then you need the leadership level people who can devise the strategy, ensure it, how it is effectively implemented. So you need people in all these areas. So we need to work on making people suitable for working in these areas. That is what capacity building in solar sector is. So the structure in our country, how we are in any sector, how we are trying to meet this requirement. For example, in solar sector, there is a program run by the ministry which is called Surya Mitra. It is a ministry's program run by the National Institute of Solar Energy. Here the candidate is ITI and they are given a training on solar systems for 3 months. which include a 15 days on-job training also. Then there are ITIs also, which conduct these programs. Then to streamline, to coordinate all these initiatives, Skill Council for Green Jobs was formed some years back, so that is also there. Then polytechnics are there, which cater to the diploma engineering students, and then engineering institutes, engineering colleges, and other higher educational institutes. This is our system or ecosystem. But what are the challenges which we are facing? And since we have industry representation also, I hope he'll agree with this. These are the points which I have taken from the last year's Chief Secretary's Conference, December 2024. The problem which the industry is facing is that one of the important problems is the people who are trained are not, the quality of training is questionable. High attrition, people leaving the sector. The quality of trainers is also sometimes questionable. Then there is a regional challenge which has come up, because solar, especially the manufacturing, has come up in pockets. So some of the pockets you see people getting trained, there are facilities. Some of the pockets there are no such things. Low entrepreneurship, commercialization. Training and skill development, lack of training and skill development in new and emerging technologies. And the need for gender inclusivity. So I want to take a minute on this point. The energy sector traditionally has been a male dominated sector. And I believe one of the reasons was this: the traditional grid was having some large size power plants, which naturally are located in outskirts, in remote areas and all. So maybe women did not find that suitable for work. But this solar energy is, by its nature, it is a decentralized source. You are installing a plant in your university or your college, you are installing a plant in your house, so it's a decentralized. So this is a good time to bridge that gender imbalance, that gap which was there in the electrical energy sector. So this is another area of importance. So these are the points I have mentioned here, because the majority of students are from B.Tech background, so some of the points may not be of that interest to them, but I have mentioned this because I have the industry participation and those are the host of this program. So that is why I have to flag their issues also. So this I am skipping because it is again on the lower level training, which may not be of much of interest to the students here. But this will be of interest to the students here. So I have talked about the entry level issues. Now I am coming to the engineering level thing. So why I am saying that engineering education need to catch up? Again, as I have mentioned, because I have some idea of the academic side also. So maybe there are some institute or some departments who may be at a different level, not having exactly those gaps, but it is a general thing. Or maybe you will realize that these gaps are existing in our system also. So see, this is our, whether electrical engineer or non-electrical engineer, you can understand, you can appreciate, this has been our traditional way of electricity generation to utilization, and it's a sort of trickle down approach where there are large generating plants and then you are transmitting electricity, then you are distributing, then you are consuming. This was and this system has been working for many years. Now, so how solar energy has changed that? I hope some of you are aware of the working of most of the solar systems which are getting installed are in grid connected mode, and in grid connected mode a plant can import electricity from the grid as well as export it back. That means you are a bi-directional, there is a possibility of bi-directional flow of electricity at the distribution side. So what is happening now, the distribution system it has started to resemble the transmission system. the challenges, the issues of distribution system may also be reflected on the transmission side. Then there are many other things also. For example, see, conventionally, the coal-based system, despite all its problems, it has been a very friendly friendly system for managers, grid managers. You can very easily, very conveniently manage the system. So what was the system? You need to forecast the load, and based on that forecast, you planned your electricity system, generation systems. Now, if you are replacing most of the system with solar energy plus wind energy, now solar energy is available during sunshine hours only. During sunshine also it is variable. Wind energy is much more variable. So what, and load already is variable, you do not have any control on load. So now you have constraint on both the sides, whether generation side or the load side. So how do you manage the grid? So you need much better forecasting on both the sides now. And you know, solar forecasting is a difficult job. So this is a challenge. Another thing which all the electrical engineers know, that conventional grid had large number of rotating machines, and the inertia of those machines was helpful in absorbing minor disturbances. In this system, there are no rotating machines. Solar energy, you are getting actually output AC from the inverter. Inverter is a static device, so there is no inertia. So this is zero inertia challenge. This, I hope some of you have heard or read or worked on this. This is wherever you are having a large penetration of solar energy, this challenge is, we are calling as the duck curve challenge. So this is our conventional load curve, which we all have studied, some peak in the evening and then settle. But if this person, if it is a household load curve, if this person installs a solar plant, then at the time of sunrise, its major load is being catered to by the solar plant. So its withdrawal from the grid is reduced, and as the solar generation increases, as the sunshine increases, the withdrawal keeps decreasing until at the time of noon the withdrawal will be minimum, and then again it will rise back to this. So this is actually sunrise point, this is sunset point. Now the challenge is, if there are large number of consumers with the same pattern, then the grid withdrawal may get to a point where it becomes very difficult to maintain the grid stability. This has happened in smaller countries or smaller utilities already, and some utilities had to actually convey to the consumers that please switch on some appliances, please consume something, we will pay you for your consumption. This is also. So this I am not sharing, this does not mean that the transition to solar will be stopped or it will be reduced because of this. No, that is a reality now. This is one of the examples of how the new grid is behaving and how we need to understand these things so that we can address these challenges and work on the solutions. Then this is another example I want to share. When we talk about climate change, sometimes we miss this point. The whole electricity setup is open, in the open. So any environmental challenge, any disaster, first casualty is usually the electricity network. Now, for example, if temperature is by routine crossing 45 degrees daily, then it is impacting the equipment also, which are working in the outside. So this is another very important area where we need to give some attention to. So the questions which which are in front of us, how we need engineers who are aware and capable of this change and the new system which is coming up, how to manage, how to design, how to address the challenges, because this new system will be considerably different from the system which we used to study. So the thing is, every engineering department has to review. Maybe some of them have already done the review and they are following these changes. And if some have not done this, they need to do this, because this is important from the point of view of industry, nation, as well as the students also, because your employability is dependent on how much you are aware of the recent challenges and their solutions. This I usually cite this example that we always say that engineering education is facing a challenge, that some of the second level colleges are not getting students like they were getting for earlier. So maybe one of the reasons is maybe we are missing connecting the students with the actual real world societal problems which they can work on, they can solve on. This will come later on also. In fact, IIT Bombay did a study where it was clearly established, and it is, you would say, common sense also. When you work on real world challenges which you can see, which you can experience, then your involvement in your studies, your understanding is better than working on abstract concepts. So this is one more point which I wanted to make. See, this energy sector or this new green energy, this green energy transition is a truly an interdisciplinary, multidisciplinary, transdisciplinary area. But the problem which most of the institutes, most of the universities have, it has been expressed by somebody very well. The world has problems, but the universities have departments. So often we are not willing to look beyond the wall of our department. And the solutions to real world problems are actually interdisciplinary solutions. And this is a classic example of this energy transition. You need people from different backgrounds to address this challenge. So this is, I won't say this is really an interdisciplinary thing, but at least it is inter-departments thing. In most of the colleges, computer engineering and electrical engineering have also walls in between them. But I don't think any engineering setup now can work satisfactorily without substantial digital intervention. If some of you can recall this 9-minute switch off call by the Honorable Prime Minister during COVID days, and you must have read how electrical engineers were expressing the concern that grid may not withstand this change. And you see 1/3 of the load was switched off, but still the grid was managed. One of the important factors was the already ongoing digitalization in the grid. As somebody has rightly pointed out, the new system is actually using megabytes to move megawatts. This is the essence of combining the digital technologies with the electrical engineering. There are many examples. I am just passing through these. And this is another very important aspect. Safety of grid has always been important, but once I am solarizing it on a large scale, see, earlier you had selected power plants. They were sending you the electricity. Now, in the new system, you have large number of distributed power plants. So as the number of nodes is actually increasing, naturally the vulnerability is also increasing, and we need to ensure that. And plus digitalization is also having some challenges with it. So it has to be secure enough, because as I have in the beginning I have said, recently the example of European countries we are seeing, we cannot we cannot allow the failure of grid in the modern system, modern society. So this I have already somewhere I have mentioned, but I am sort of it's a recap. Actually, my suggestion or the essence of my talk is that this is a huge transition occurring in terms of energy generation or use and consumption, and there are many other things which I have not covered because of time constraint. How we will be demand side management. This is another important thing which the electrical engineering students should know. So there is a need to talk about it in our campuses and highlight the role of every one of us, and especially those who are in the field of energy. They have, you see, so much is happening, and when such a huge change is coming up, there are challenges and there are opportunities when there are challenges. And those who are students now or faculty, naturally, when if you address those challenges, it will be good for the nation as well as for your own career. So this we have to ensure we address the relevant questions at different levels, BTech, MTech, PhD. We need to ensure some bridging also. If our students have not covered some of these concepts, we can have a short-term course, and we need to somehow work on this, and I think this center can explore that, because those engineers who are in the field, they are also finding it difficult because of the rapid changes. So if you can think of reskilling these people. So I say that everybody has to work on this: teachers, administrators, regulators, students. And the very important point is industry connect with the institutes. This is something which we all agree that we have been sort of lagging in this. So let us bridge this gap and have an active collaboration. I have usually when we talk of industry attachment or collaboration, so our focus is that let us send the students for internships. But the student's first point of contact when he joins a program is the faculty member. So my opinion is that if the faculty is somehow connected in some way with the industry, then maybe we will be able to solve this issue in a better way. Connect of faculty will lead to connect of more number of students in a better way. So this is in the end, I want to say that trainings I have talked about, and there are challenges because, but since the audience is different, I am not taking that in detail. But in terms of the engineering level, review and reorient the engineering education in the light of green energy transition. We need, in fact, I tell you, many of the major countries have already devised the documents which have identified that in light of these changes, these are the important research questions, these are the topics on which we want our students to be aware of, to be competent of, and then they have developed documents related to that. So it is high time we should also do this now. Research fellowships dedicated to solar energy, creation of incubation centers and innovation. You see, in last few years, this incubation thing has been given some push, and we have seen very good results. In fact, one very important equipment used in solar testing, it was not manufactured in India, and a startup from one of the IITs, they developed it, and our institute purchased from that. It is equally good with I think a cost of 20% only compared to the original one. And it needs a high level of coordination among policymakers, industry, academy, and training institutes. Last, I want to talk about the National Institute of Solar Energy. And the institute is trying to work on all the things which I have mentioned. So it is an institute of Ministry of New and Renewable Energy, and it was established in 2013 by converting the solar energy center which was there. So our mandate, we divide our work into 4 verticals: research and development, testing and calibration, consultancy, and capacity building. And we feel that like I have told you, those who are working in the sector of energy, Institute on solar energy has great opportunities because this whole transition is focused on solar energy only. This is our infrastructure and facilities. We have very good labs related to solar and green hydrogen. And I am sure many of the students from IIT Delhi have done their internships, and some are already doing. And some of you who are interested, you are welcome. You can come and do your research work, do your internships, or you can come just for a visit to see what is happening and what all we offer. So we are working in line with the national requirements. I am mentioning these requirements because this may be useful for you also when selecting your research topics or your higher studies and all. So as I mentioned, development of higher efficiency solar cells and modules. This is one of the priorities. Domestic manufacturing of cells and modules. Testing and validation infrastructure for those modules which you are developing. Addressing the challenges introduced by high penetration of solar energy. As I have mentioned, forecasting is a priority area now. How I can forecast solar energy in a better way, how I can forecast load in a better way. End of life management. So solar panel is a durable thing, but everything has some life. So after 25 years, 30 years, when it completes its life, what happens to it? The sustainable, because it is all being done in for sustainable development, so that should be ensured that it's either it is reused, recycled, or disposed in an appropriate way. So this is another, I would say, this is a high priority area now, and anybody who is interested, if you start working in this area now, you can develop a very good career. Then I have already mentioned new areas for solar deployment, floating agri, BIPV, etc. And trained manpower is a requirement, as I have already covered. So I think this is all from my side, and I am open for your questions. If you have any questions, please ask. I hope I am on time.
Hi, Dr. Rihan. Fantastic talk. I had two questions. One, you already talked about regarding the renewable solar panels. So, how for the e-waste part. So that is a fantastic inline requirement. The other one that I was wondering if you could throw some light on the storage solutions. That is on the batteries when it is concerned, where lithium is a concern. So how do we store this production of the PV from any source that's coming up? Thank you.
So these are two very important questions. One is related to the concern of when we are developing solar system at such a large scale, and then the tons of waste which will be available, how that will be addressed. So as I have said, this is a priority area, but there are certain specific challenges to this sector. If you compare it with, say, battery sector, so battery has a very good recycling system in place. One of the challenge of this technology is its durability. If something will be in the field for at least 25 years, so it becomes very difficult to ensure the response. Who will be responsible for that? So if you make the manufacturer responsible, then how it will be implemented after 25-30 years. So this is a question for all the countries. It is not specific to our country. Then the second question is related to technology, mechanical versus chemical. Third question is, if you develop some centralized facilities only, how the panels will be brought to that facility. We have discussed with industry also. So as of now, industry does not see this sector as financially viable sector. They don't see money in it compared to like battery system. So what I think is initially it will require some government support plus some mandate, and then once a system is in place, then it will take off. As far as I know, it is under consideration at the highest levels actually. And one pilot was also done in Tamil Nadu in 2019 or just before COVID. So there were very good learnings out of that. All this is under consideration, but I agree this is a very important concern and it should be addressed. Second, you have mentioned about the battery storage. So we are heading towards a situation where definitely during daytime you will have more generation than required. We will reach that situation. Now the challenge is how to, like I have mentioned, given the example of one of the utility that, so one option is I store that, but storage, the thing challenge is the lithium ion is the most suitable one, but its cost as well as the dependence. You are completely dependent, almost completely dependent on imports. So that is why I take this challenge in this way, that we need to work on storage is imperative, but we need to work on reducing the requirement of storage. Now, reducing the requirement of storage, one option is demand side management. And you will see it. I think Rajasthan has already come up with this. Regulation has already been changed. What will happen? You will have a two-part tariff now at every level, even residential consumers, where the nighttime tariff will be high compared to the daytime tariff. So we'll push people to shift their usage from night to day when solar energy is available. This is one thing. Then green hydrogen also comes in this whole picture. Can I use some of the solar excess energy available to generate green hydrogen which can be used in industry? So I see it will be a combination of all these. I cannot simply calculate the requirement of storage and say, no, this much storage is required. First, I have to work on reducing the requirement of storage. And one more thing which is happening is the beyond lithium ion. So, for example, in EVs, lithium ion has no parallel now. But in grid storage, there is no challenge of space. So I can go for larger batteries also. In behind the meter, in the residential houses, I explore some other chemistries like sodium ion is being explored, flow batteries are being explored. So storage is an unavoidable piece of this whole system. But only thing is how can we reduce the requirement of storage. So I feel this will be a combination of all these things. Any other question? Oh.
Thank you, sir, for such a great session. So I would like to ask that how at the local consumers end we can motivate them to adopt the solar power, and moreover you must have heard about the bidirectional flow of energy as you have mentioned. So in other countries there is a system where we can actually
Zero export device.
we can install the solar on our rooftop and we can sell the power to the grid also. So will it be possible in countries such as India where the power grid is such
Okay.
on a large scale?
See, this system which you are seeing now, we call it net metering system, where you have, suppose you have your import is 100 units, your export is 20 units, so your bill will be on 100 minus 20 is equal to 80 units. There is another system which is called as gross metering system. In gross metering, what happens? Whatever you are generating, you are not using any of that electricity and you are selling whole electricity to the grid. So we started with that only. Initially, when there were no takers for solar energy, so it was said that you install solar plant and this utility will purchase from you at a rate of 30 rupees a unit. So once it started taking off, then it was changed to net metering system. And this net metering earlier was available for every type of consumer, even institutes, industries and all. Then it was restricted to agriculture and residential only. And I I see it that in a couple of years, it will be further restricted. The next stage of this system is called net billing system, where your import will be charged at say 6 rupees and your export will be paid at say 3 or 4 rupees. So we are heading towards that. So this is a natural progression of as the technology is getting adopted, it is getting financially viable, you are restricting the benefits. Otherwise, it becomes difficult to manage.
Sir, first of all, thank you very much, sir, for such an insightful session. Sir, you have explained one curve, no, sir, duck curve. That is, whenever DG is giving power, there may be
Solar,
solar.
cells.
I mean, when the solar PV is generating power, there may be a chance of grid imbalance. Sir, nowadays, I mean, I have heard about this latest technology, sir, that is Advanced Distribution Management System, ADMS. Particularly, sir, this is, I mean, I have done some literature review and found that this is being implemented in smart grid, sir, where DG is being installed, like irrespective of any wind or PV, whatever it is. So, sir, as part of this, as you have just now you have told regarding demand side management, like load shifting, one criteria. So, can we use this term called load curtailment, sir? Like, for example, let us say a wind or PV itself, PV or wind, whatever may be, in the chance of peak demand, we are, let us say, curtailing by our load, the operational load by, let us say, a 10 to 30%. That is a fixed criteria. So, is this helpful to maintain balance, sir, in grid?
So basically what you are saying is, and I agree completely to that. So to manage this new grid, you will need a system where you have much more visibility on the consumer's uh, utilization or use of electricity, and that you are already going towards by installation of smart meters and all. Smart meters are actually giving you that idea. Smart grid, one of the main features is it should have prosumers, two-way communication with customers. But there are practical challenges with this. So when I theoretically talk it, it is simple that I have connection with all the consumers through smart meters and ADMS. If I see that now this problem, I am unable to manage the grid, let me, here the problem will be reversed. Let me, it will not be curtailment of load, it will be switching on the load. So, but the challenge is whether curtailment of load or switching on the load, how much the consumer will allow you to interfere in their day to day, rather hour to hour functioning or use of appliances. So that is a practical challenge to that. But the communication and smart meters, availability of data is the key. Data plus communication, you will be in a better position compared to right now. This is true.
Hello, sir. Greetings. First of all, it was a very informative session, sir. I have a small question. In fact, I have two questions, sir. First of all, I would like to ask you, sir, as you talked about numbers, how the solar energy is going to grow, like in terms of PV capacity. Per se, if we talk about numbers till 2050, if you could just give me an estimate. And in case of a situation where another renewable energy technology comes up, per se, do you see a saturation in solar energy in the coming years, say till 2050 or 2060? And another question, slightly from, because I come from environmental engineering background. So since we have introduced cadmium telluride panels in ALMM list last year in 2024, so how do you see the market share, whether it is going to change? There are new technologies like perovskite and OPV present. So are they going to take over the market? And if so, are we going to replace such huge installations like 107 gigawatts that have just happened? Are we going to replace those panels because of good efficiency?
So I have lost track of your earlier questions actually. So can you repeat briefly what was the first question?
So the first question was if you could give me a number like till 2050 and any new technology that could come up, and then you please talk about cadmium telluride panels and market share. Thank you.
So see, none of us has any personal connection with solar energy, this solar PV technology. We have adopted it because as of now it appears as the, I won't say the best solution, but among all the available solutions, it is the most workable solution in eliminating coal from the system. So as of now, we don't see any other technology coming up in such a big way that completely replaces solar also. But even if it happens, naturally the world will take that. So I don't see any problem in that. Second is, you have talked about cadmium telluride. As of now, I see these two are not competitors actually, because of the performance, the kind of performance you are getting from crystalline silicon modules, you will not get from these modules. And actually, these modules are for that, especially those areas where the crystalline silicon is not useful, or you cannot use that. But still, again, I usually say this is a field which is consistently evolving. So what will happen? Last 5-6 years back, everything was polycrystalline. Now everything is monocrystalline. Then suddenly it is bifacial has come up. Then TOPCon. First PERC came and then TOPCon, and this first HJT plant in India is also operational now. It will also come in ALMM in 15 days or a month. So it is consistently changing. How it happens, we all have to see actually how it evolves. As of now, the projected numbers are like this only, that if I want to achieve net zero by 2070, and if net zero by 2070, then energy sector net zero will be somewhere between 2060 to 2065. Then we will need around 5,000 gigawatt of solar energy. This is as on date.
Good evening, sir. I want to ask, like, how is the TMD is going to play the role in PVs?
TND?
TMDs.
Transmission and distribution.
No, sir. Transition metal die chalcogenides. That it's photovoltaic materials.
No, I don't have any idea of that. Can you tell me something about this if you have some idea?
Sir, I was reading about this material which is synthesized and is having a photovoltaic characteristics.
So I'm not a material person, so I don't have an idea of that.
Thank you, sir, for great session. I just have one question, that as you mentioned about the challenges of solar, so I would like to listen about the challenges related to wind also. Like, we are focusing so much on solar, so where is the problem in the wind?
So, as I said, I am not a wind person, but this world is very practical actually. It is applicable to me as a person, to you as a person, as well as to a technology. So any technology which can become financially viable on a large scale is adopted. So that is the basic principle. Now the challenge with wind is that it is not, you cannot install it anywhere. Where the wind available is sufficient to give you the minimum generation, there only you can install a wind plant. So in our country, there are selected locations only, but still the wind sector is growing, and it has already crossed 50 gigawatt of capacity in the country, and it is a target to have 100 gigawatt by 2030. And one important thing about wind sector, maybe you are not aware, this is a completely indigenous sector. The manufacturing of wind turbines and other associated components is completely Indian since long.
Thank you very much, sir. We
No,
can
no,
take one more question.
You can allow him, no issue.
sir, my question is, what is our current plan for managing and recycling of the solar PV plant once the life is?
So recently, if you have followed this, the government included solar panels into e-waste rules already existing. And as the policy is evolving, so what they have done is they have given a mandate to all manufacturers and the dealers that they will have to store the panels, discarded panels in their facilities till 2035. This mandate has been given to them. This is a recent development. So what the idea maybe is that in much before that, there some policy will come up and then it will be implemented.
Thank you, sir.
So one more question we can take. Anyone else? Okay. So with this, we can end the question answer session.
Okay, thank you everyone.
Thank you, sir, and thank you everyone for making the time to be here and for your continued support. Your presence has made this event truly special. Now it's time to show our respect and gratitude and appreciation to our esteemed guest, Dr. Rihan. And for that, I would like to request Mr. Jitendra Rautre, Head CSR Renew, to present a token of appreciation to Dr. Rihan. Thank you, sir. Thank you for being with us. Now, as we are near to the end of this unforgettable evening, it's time to express our gratitude to all present here. And for that, I would like to request Professor Sumit Chattopadhyay, Co-Coordinator of the New Center of Excellence, for the closing remarks and vote of thanks.
So good evening once again to all of you. And my sincere gratitude to Honorable DG Nice, Rihan sir, for his enlightening speech. Particularly, I am sure for the research scholars, it will open many new research areas, concepts, and also it will open the scope of joint work with NICE. And also I express my gratitude to everyone here who came and spent this nice evening. So with this, I would like to conclude this session. And I request you for joining the snacks waiting outside and have networking and socialization over there. Thank you so much.
Thank you for being the wonderful audience. It's time for high tea and snacks. Everything is placed outside. Please have snacks also.